Hey friends, in earlier video I have already discussed about the transport layer and we talk up to the user datagram protocol. Just to give you a quick recall, let me repeat those slides in front of you so you should understand what we have discussed. But the objectives of the today's session is to start with the transmission control protocol, and that is TCP. But what are the important concepts that we have already covered in the last video? I'm going to repeat it just for a sake of completeness, and then we are going ahead, right? So let me show you that. This is the outline that I said. We will discuss first the need of the transport layer. We already talked about in the previous video. If you missed it out, please watch that video. These are the functionalities of the transport layer. Like we say that transport is a true end-to-end layer. It provides port addresses, it does error and flow control, as well as it does data transmission between the process to process, whereas your IP does the data delivery from host to host. It also does the segmentation, and there are two famous protocols that we're gonna study. One is the UDP, that is the user datagram protocol, and the second one is the TCP, which stands for Transmission Control Protocol. So, this is the very quite self-explanatory diagram that I have already explained to you, but let me tell you, your data link layer will do node-to-node delivery. You can see in this diagram, your data link layer will do node-to-node delivery, right? And your IP address, that is your network layer, will do host-to-host delivery. You can see in these two machines, the delivery is done by your network layer. But when it comes to the process, as I used to say that, let's say there are two instances of the browser and both are working with the different, server. Let's say one is communicating with the Google server, another one is communicating with the Yahoo server. Then in that case, the process to process differentiation, right, would be done by the port addresses. So basically, a process to process delivery is done by the transport layer. One of the important things that I already explained in the last video is how it gives the port addresses, what is the importance of it, what do you mean by a socket address, what would be the range of the port addresses. I already explained you that port address has a 16 bits of length. There are something called a well-known port numbers, right? And this is what you mean by multiplexing and the demultiplexing. And then we differentiated the TCP and the UDP. We said that the TCP is connection oriented, UDP is connection less. Then we talk about the error control, why we need error control at the transport layer. This diagram has clearly explained that error control is there at the data link layer, but it is not taking care about the data link layer, and that's the reason you need to have an error control at the transport layer. And then we started with the user datagram protocol. I said the well-known services with some good examples. Then I explained you the UDP header. So I wish, if you are still interested into the detail of all this concept, please watch the previous video. Let's start with the content. Today, we're gonna talk about the transmission control protocol, that is TCP. So basically, TCP is a connection-oriented protocol. It creates a virtual connection between two TCP, right, sender and the recipient. In addition, TCP uses flow control and error control mechanism at the transport layer. The way you have a error control and flow control mechanism at the data link layer, similarly, the same kind of mechanism you have at the transport layer. Look at this diagram. On the left hand side, you have a sender, and on the right hand side, you have the receiver process, right? Now, the job of the sender process is to push the data towards the receiver process. So basically, the logical concept is that there is a pipe between the sender and the receiver. And that's a reason why we call TCP as a byte or a stream oriented protocol. So what you have in between is a logical connection, which we used to call as a stream of bytes, right? So you can see the pipe clearly in the slide. Now this is a very important diagram that you should understand very clearly. You can see, guys, on the left hand side I have a sender, on the right hand side I have a receiver. Now, on the left hand side, we have a sending process. On the right hand side, we have a receiving process. As I have explained in the previous slide, there is a stream of bytes in between sender and receiver. Now, you can see there is a concept of buffer, and that buffer is actually the sliding window buffer. So what you do is you keep writing, application layer keep writing the bytes into this buffer, and you keep pushing to the stream. And then at the receiver, you take one by one bytes out and you pass it to the application layer. So this is how sending and receiver buffers are working. So you can see in the sender and receiver buffers, there are many sections like not sent segment from the sender, send segment, and it also points to the next byte to send. So it keep rotating like this, right? And similarly at the receiver and you have a next byte to read pointer, not read data, and next byte to receive in an empty buffer. So that has been clearly mentioned in this diagram. Now look at this diagram. On the left hand side you have a sending process, same as earlier. On the right hand side you have receiver process, right? The bytes of data being transferred in each connection are numbered by TCP. So each byte used to be numbered, right? The numbering start with a randomly generated number. What I mean by that is, suppose I'm sending 1000 bytes in a segment. The meaning is that I'm consuming 1000 sequence numbers. That means when the communication is happening with the TCP, you are consuming a sequence number for every byte that you transmit. This is very important thing that you should understand here in the diagram, right? So if you look at this example, let's say there is a segment 1 and the length of the segment is, let's say, 1000 bytes. So my first byte number is, let's say, 10,001. Right, and the last byte number is 11,000. So as I started with 1 and I'm ending with 0, I have 1000 bytes into the segment 1. So if you look at the TCP header, the sequence number is going to be the first byte number, and that's nothing but 10,001. Similarly, you look at the segment 2, because segment 1 was ended at 11,000, I supposed to start the segment 2 at 11,001. Right, so whatever the first byte number that you have in a segment, that's supposed to be the sequence number, right? The value in the sequence number field of a segment defines the number of the first data byte contained in that segment. That's very important, right? So every byte, for every byte you are consuming one sequence number. Now let's talk about TCP header. See, we already know that when your application layer generates the data will be passed to the transport layer. And as I said, friends, at transport layer, I have two options. One is TCP, another one is the UDP, right? Now, when I say TCP will add its own header. As we have discussed in the previous video, UDP header length was 8 bytes. Now, when it comes to the TCP header, so like this, you have a header and you have a data, right? Now, if I expand this TCP header, it has a 5 rows like this. You can see the 5 rows. Each row, which has been displayed in the white color, is of 4 bytes. So if I count like this, 1, 2, 3, 4 and 5 rows. That means each row is of 4 bytes. I have 5 rows. That means minimum length of my TCP header has to be 20 bytes. And after that white portion, you can see the sky blue portion where it's an options. And options are optional. If you wish, you can use it. Otherwise, you can ignore it. And for options, you are getting additional 40 bytes. That means, guys, the maximum length of my TCP header could be 60 bytes and minimum length could be 20 bytes. Now, let me expand the TCP header. See, the first row, which is of 4 bytes, has been divided in 2 equal parts. Left hand side is the source port, which is 16 bits. Right hand side is the destination port, which is again the 16 bits. Then you have sequence number, which is again 32 bits. Then you have an acknowledgement number, 32 bits. Then the fourth row is, let's say, divided into 2 equal parts. So on the left hand side you have 16 bits, and again on the right hand side you have a 16 bits. On the right hand side you have a field called window size. You have a field called window size. Now what is the use of this window size field? This window size field is used to implement the flow control, right? We will talk about that, how it will do that. But you have to understand this window size field of 16 bits will help you actually to do the flow control in the TCP. When I say flow control, what do you understand? For example, let's say I have a supercomputer and I have a personal computer. Now supercomputer might be throwing the data at very fast rate where the personal computer cannot cope up. So basically what personal computer has to ask the supercomputer to slow down. Now the question arises here is, guys, how the personal computer will ask the supercomputer to slow down. In order to tell the supercomputer to slow down, you have to write some value inside the window size field. and that value actually help you to do the flow control. That's what I mean by the flow control is done by the window size. The length is 16 bits. So you understand what I mean by the 16 bits, right? On the left hand part, on the fourth row, first 4 bits are header length. And how many bits I have? 4 bits. Now please understand, as we discussed for the IP header, the header length field will give you the length in terms of 4 bytes. That means my header length 4 bits minimum could be all 4 set to 0, or all 4 this can be set to 1. So when I set all these 4 bits, let's say if I talk about this header length, right, what I can do is I can set all these 4 bits to either 0, or I can set all these 4 bits to 1. So let's say when I set all these 4 bits to 0 like this, right, what decimal value I will get, the guys? I will get the decimal value 0. Right, and when I set all these 4 bits to 1, what the decimal values I will get? I will get the decimal value 15s. Now please understand, as I said, this header length will give you the length in terms of how many bytes? 4 bytes. That means whatever the decimal values you are getting here, you need to multiply by 4. So my 15 should be multiplied by 4, and that will give me the 60 bytes. And that's how the maximum header size could be the 60 bytes. Right? Now please understand, what is my minimum header size? It's 20 bytes. That means my header length field has to be 0101. Right? If it is less than this, probably you have to assume that you received the TCP segment with an error. Right? So this is all about the header length field. After that, few bits has been reserved. Actually, this TCP header is bit earlier version, where you have 6 bits reserved, but nowadays only the 4 bits are reserved, and actually you have 8 flags. But in this video I'm going to talk about only the 6 flags, right? So you can look at this diagram. You have 6 flags. The first one, which is very important, is the SYN. You can see here SYN. This SYN is used to establish the connection. So these all are 1-bit flag. See, when there is a 1-bit flag, its value could be either 1 or it could be 0. So if my SYN is 1, the meaning is that my sequence number field of the TCP header is in use. Similarly, you have an acknowledgement field. Again, it can have 2 values, 0 and 1. If acknowledgement is 1, the meaning is that this acknowledgement number field of the TCP header, which has been represented in 3rd row, is in use. If acknowledgement field flag value is 0, the meaning is that acknowledgement number is not in use. Right? Similarly, you have something called FIN, finish. It is used to terminate the connection. See, in the earlier slide, we have looked at TCP's connection oriented protocol. That means before it transfers the data, it has to establish the connection. Now see, it cannot be done by magic like Khulja Sim kind of things. It's not possible, right? You have to establish the connection. How TCP will establish the connection? So it does 3-way handshaking. Now the question is how you implement 3-way handshaking. The 3-way handshaking mechanism is implemented by flags. I already said SYN, SEK, and then at the end of the data transfer phase, you need to break the connection. You need to terminate the connection. How to terminate the connection? You have to set the header or control message with FIN, that is finish equal to 1. If it is 0, that means you don't want to break the connection. So you have to set FIN equal to 1. Similarly, the client and server, let's say, communicating, or the sender and receiver are communicating, and they got confused about the sequence number of the connection. What they can do is they can set RST equal to 1. That is to reset the connection. Similarly, guys, I have already explained you the 4 flags: SYN, SEK, FIN, and RST. Now there are 2 more flags. One is the PSH. PSH yani push. What you are saying is, let's say you have some internet active applications like Telnet, and you wish that your transport layer should not do any kind of optimization. You expect that immediately you forward the packet without doing any kind of optimization. Then in that case, you have to set PSH equal to 1. So that your transport layer will not do any kind of optimization. It will send the data immediately. And finally, you have URG. Again, for URG, it could be 0 or 1. When I set URG equal to 1, the meaning is that your urgent pointer, which is in the 5th row, right hand side part, guys, this one, urgent pointer 16 bits is in use. When it is in use, when I say that URG is equal to 1. Now you can ask me a question, what is the use? See, the use of the URG is that if I have some control information to be passed before my receiver processed data, probably that message I can put here in the urgent pointer. Okay, this is the data you process first and then you process in the sequence. And when I have to say the receiver कि urgent pointer is in use, I have to set URG equal to 1. I hope all the flags are clear to you. Window size I already said. The usage is to do flow control. Now last two fields of the header. One is the urgent pointer, I already explained, and the checksum. You know what is the use of the checksum, guys? Yes, checksum is used to do error detection. Right, so in this video, what we have covered is TCP is byte oriented, right? It does streaming, how it maintains the buffers, and finally we discuss the TCP header. In the next video, I'm going to explain you how TCP will establish the connection and how TCP will terminate the connection. If you understood the concept from the video, please don't forget to subscribe to the channel. Thank you for watching, guys. Thank you.